Number 11, again, just a problem with like radicals. These are the same root, cube root, and the same radicand, 9 squared. So that means this is 4 times, you can think of this as x. These are both the same thing, so I'm just going to think of it as like 4x plus 8x is 12x. So 4 times 9 to the 2/3 plus 8 times 9 to the 2/3 is 12 times 9 to the 2/3. It's just combining like terms. Number 12. At first glance, you may think I can't do anything. These are not like radicals. But we can simplify cube root of 40. You know, think about, is there a perfect cube that goes into 40? Well, yeah, because 8 times 5 is 40, and 8 is a perfect cube. So I can rewrite cube root of 40 as cube root of 8 times cube root of 5. So this is cube root of 5 plus, that's 2 cube root of 5. And now all of a sudden we can add these. Cube root of 5 plus 2 cube root of 5 is 3 cube root of 5. For number 13, we're taking the cube root of 27 times the cube root of q to the 9th. And whenever you're taking the cube root of a variable to a power, you can just divide this number by this number, because remember, this is the same thing as q to the 9 over 3. So the cube root of q to the 9th is q cubed. And then the cube root of 27 is 3. Over here, now I can't use an exponent property here because these bases are different, but I can break this up as 5th root of x to the 10 over 5th root of y to the 5th. And again, just divide 10 by 5, so this is x squared, because another way of writing this, just to reiterate, this is the same as x to the 10/5. Sometimes it helps to think of them as fractional exponents, so that's x squared. This is the same as y to the 5/5, which is just y to the 1, so y. Number 15. So I do have exponent properties I can use here. First off, I can reduce this fraction, 6 over 3 is 2 over 1. Okay, so I've got 2 in my numerator. And then I've got x to the 1 over x to the 1/2, so that's x to the 1 minus 1/2. And I have y to the 3/4 over y to the 1/2, so that's y to the 3/4 minus 1/2. So 1 minus 1/2 is 1/2, so this is 2x to the 1/2. And 3/4 minus, I'm going to think of this as 2/4. 3/4 minus 2/4 is 1/4. So this would be the simplified expression. Number 16. So square root of 9 times the square root of w to the 5th minus w times the square root of w cubed. Okay, and remember this is an understood 2 for a square root. Okay, so we know that the square root of 9 is 3, but let's really think about what this is saying. This is saying the square root of w times w times w times w times w. And so in order to pull out my w's, I need pairs. There's a pair, there's a pair. So that means I get to pull out w times w to the front. So square root of 9 is 3, w times w is w squared, and I'm left with a w under the radical. Okay, minus, let's approach this one the same way. This is saying the square root of w times w times w. So I can pull out a w to the front. there's already a w out front. So I have a w times another w is going to give me w squared, and then I'm left with a w under the radical. And now they're like radicals, see? So 3w squared times root w minus 1w squared times root w is 2w squared times root w.